Welcome, safety enthusiasts, to our latest SRES Fireside Chat. I'm Jody Nelson. You may hear I'm a little bit sick right now. One of the joys of having children in the public school system, you get to test out your body immune system, and I lost this battle, but I'll get the next one. So I'm joined here with my colleagues Gokul and Bill. They should both be familiar faces from our earlier discussions on safety and AI. But today we have a very special guest with us, Eduard Dojan from our training and certification partner, SGS TÜV Saar. And today we're going to be diving into ISO Pass 8800. We've discussed this a little bit in the past in some of our other fireside chats, but we're going to dig a little bit deeper into this safety standard, which is for AI-based systems. Now, it is currently in the PAS. For those of you not familiar with this, that's a publicly available specification. Basically, the PAS allows us to create, or allows the organization or the industry to create a kind of an accelerated timeline to meet urgent demands. So to release information for us to use before or while the full international standard continues its own development. So it was published in December 2024. Some of you may have attended one of our first trainings. We actually had our first training on AI safety with Eduard presenting during that time. That was back in December 2024, right? Actually, the same week it was released. So we've had a chance to work with the PAS, across multiple standards since then. So we wanted to kind of share what we've learned from a consulting standpoint, and Eduard's here to kind of represent more from the assessor auditor's point of view. So we want to talk about, things that we see that are working, where maybe teams are struggling, and how we're seeing organizations approaching it, for audits against the pass. And then we'll kind of talk about also what looks ahead for us. When the formal ISO 8800 standard is officially released. We don't expect that for a while, though. It's scheduled right now to be later in 2029. But we'll talk about some changes or clarifications that might be coming in the standard as it's maturing. So with that, Eduard, well, welcome. Maybe could you start out by introducing yourself to the audience here?
Yes, thank you very much. So welcome to all, and a short introduction from myself. I'm from SGS TÜV Saar in Puchheim, Munich, from Germany, and I'm here responsible as a product manager for services for software and artificial intelligence. All services, assessments, audits, and so on are on my desk regarding software and especially AI. And in this artificial intelligence topics, I'm also the member of the international and the national standardization body of the ISO Pass 8800, and also of the sub-teams out of this standard. Very brief introduction, and if some question will be more, then I can also talk a little bit more. From the background informatics side, software experience for 23 years in a previous company. And sure, as an auditor and assessor at SGS TÜV, with some other experts from on our side for AI as an auditors and also assessors. That's very brief introduction.
Yeah, no, thank you. I appreciate your time here, and I think the crowd here really likes to see kind of the perspective from an assessor and auditor. And just a reminder for everybody listening, feel free to put questions into the chat as we discuss, and we'll try to answer them, live fire as fast as we can. So great. Well, thank you, Eduard. Thank you for joining us. So I guess before we get started into some experiences, I know we discussed a little bit maybe in the past about the 8800. But Gokul, could you maybe briefly introduce the ISO Pass 8800 and maybe discuss what holes it fills within our automotive industry?
Yeah, I'll keep it a little brief, and then we can sort of dig into it as we go. So sort of stepping back, we had our ISO 26262 standard, where we had the first edition in 2011, and then replaced with the second edition in 2018. In that standard, we focus more on the deterministic pieces of safety, like malfunctions, hardware, software failures. How do we address them with mitigations? And then we had the SOTIF standard, where for ADAS and ADS systems, we got into scenario-based and argument-based safety, where Of course, ML algorithms, ML models, data are leveraged in ADAS and ADS, but in the sort of standard, we consider them as a black box, right? We look at it from a behavioral safety standpoint. We don't really get into the details of what's within the pre-processing stage of, let's say, a detection model, what is inside the model itself, what are the architectures, and post-processing and supervising. We don't get into that level of detail. So naturally, we needed a standard or a framework of thinking of what could be the root causes within models, right? So when we sort of zoom into our lower granularity of let's say, an object detection model, you're going to have some pre-processing elements that are maybe more traditional, can be solved with 26262. And then you're going to have some supervisory or post-processing that's also solved by 26262. But the model itself, that's not deterministic, right? That's non-deterministic. It's very data dependent, particularly if it's a supervised model. You're going to have your training data sets, your validation data sets, your testing and the deployment. It's not very straightforward. And therefore, we want a framework where we can visualize the life cycle. We can think about the data, how to collect, how to augment and synthesize data. So we need a framework to sort of align also for OEMs and tier ones and software vendors to align on what it means to make these AI-based systems safe. So the 8800 standard is helpful in using the same language, and also now we bring in the ML engineers, we bring in the data engineers and the data scientists into the picture, and we can then talk to them about how to make these things high quality, how to make these data sets and the model also safe. So that's really the crux of 8800. It adds another sort of granularity, or it adds another abstraction level below our existing standards.
Yeah, thank you. And I can see this. I mean, I remember, we worked on autonomy, many years ago, well before this standard. And, as we were training in ISO 26262, always the question, well, I mean, how do machine learning, how do you adapt that, to that? And so it was kind of missing, right? Like we missed that gap there. And then SOTIF, we all know, it's kind of really written at vehicle level, kind of structure. So we don't really get down into the ML model itself in the pure SOTIF sense. So I guess, Bill, based on what you've seen, and you've been working on this for a while now too, what are some of the biggest difficulties in trying to align like traditional functional safety, where we have a lot of people who now understand functional safety quite well, kind of aligning that traditional functional safety practices with AI related insufficiencies that we talk about in 8800?
Yeah, no, I mean, and you and Gokul have already mentioned probably the big one or two that tend to come up in the with the projects that I work on and that we talk about. There's just a lack of ability to really drive down with the same kind of traceability. We have a concept of traceability that, for example, a top level vehicle performance or vehicle behaviors and safety are based on, perception and planning and all the things that work in an autonomous vehicle setup. But when we want to go and validate those and show that the low level combined to meet the high level, the link there, it's harder to express. It doesn't come out as directly. So we can't, in functional safety, we can often sit in a room, understand our circuits and systems and software, and really drive low level requirements from the high level requirements. It's clear what we need to do at the low level. I think when we talk about AI driven functions, that clarity is less, so that traceability is less, and there's a lot more needing to assemble verification and validation information that's really more it's more statistical in nature. It's a lot of data to show that the functions are repeatably safe in a wide variety of scenarios. And so there's a whole different, I don't know, it's in some ways a whole different style, much more validation focused, looking for potential odd, strange combinations of things, making sure that we cover a fully representative set of scenarios from our ODD is very important. And oftentimes we can't get as tight a flow down, but when we flow back up in validation, it works if we've done all of the low level processes. The thing is, SOTIF doesn't have those low level processes, right? They're just not really there. It really is, as you mentioned, very vehicle level. And so what to do with AI development, I think there's some best practice, some good thinking, some strong thinking. And I think that goes into the 8800, and that's its role is to sort of do that. that day-to-day block and tackle of safety in the AI space.
Yeah, and I mean, just thinking about all the different things from a traceability standpoint, your software development, there's a software version. Let's go back to traditionally, a software version, you may have a calibration set. So you're kind of linking to that to your kind of assessed 2622 software. But here you have a training data set, and you have validation data, and then you have the ML model itself, and then you have all these hyperparameters that can change. So yeah, it's quite complex. So I guess besides some of the technical aspects, there are new processes with respect to ISO 8800. Eduard, I guess from an assessor's perspective, what would you recommend for kind of process integration, especially for organizations maybe just starting out in ISO past 8800? They want to get into it. They're doing ML development. They want to kind of, cross the T's and dot the I's. What would you recommend from a process aspects?
Yeah. And maybe a short comment also to this traceability between SOTIF and 8800. Out of the standard, we see that the standard has a prerequisite. That means that the SOTIF aspects shall be available before we start with 8800. It's a in one sentence. And from the perspective of the TIF, I think we have the 2 or 3 requirements as a traceability to the 8800, to the machine learning. And that's a clear traceability. And also I want to say to this topic, for example, if we talk about triggering conditions from the SOTIF perspective, then they shall be refined in 8800 as AI triggering condition. That means from a SOTIF one triggering condition, there can be following 2 AI triggering condition. And the naming say triggering condition, and for 8800, AI triggering conditions. Only a short comment to that. From the audit and perspective, yes, we see a lot of questions also from the trainings on our side and from the audits also. Recommendation is it makes sense to talk with our customers before, like a consulting, before start with an audit, how they prepare their basic standards, like 26262, and how they implement the 8800 on that. So there are a lot of questions during this consulting activities that we can also reduce our audit loops with 3 or 4 loops with a lot of findings and so on. But that works very well in this way, that the basic standard, it's important to have a clear basic standard, a clear defined 26262 process, functional safety process with clear defined work products. And what I see is a lot that the customers want to update their safety plan with SOTIF aspects and also with AI 8800 aspects, that they can have a very clear traceability. And that's very well. That's very good start to that point. And that's important for the process definition. And from the perspective of the 8800, that's very similar to the standard 26262 with the process definitions, prerequisites, with the objectives, and later on also to the work products. And that with that, it will be a very clear traceability. Sure, the work product itself shall have these requirements out of this 8800.
Thank you. I think their statement on triggering conditions represents a really good model, a really good visual, right? So if we think about SOTIF triggering conditions, if we think of a camera, right, like a triggering conditions fog or a shadow underneath a bridge, which could then, trigger a functional insufficiency of that camera, where it's just, things that we have to deal with or work around. So now kind of what you're saying is, that triggering condition, we have to bring that down to the ML model level. What kind of triggering conditions do we have kind of in AI that brings out AI insufficiencies? Okay, great. Thank you. So, I mean,
and very important, maybe I can add that the AI triggering conditions then will lead to some insufficiencies, and that's the loop back to the SOTIF, because they can be have an aspect to SOTIF triggering conditions, and that's the traceability in both directions. Very important.
No, that's great, and I appreciate that. And So you kind of mentioned, 26, 26.2 and SOTIF. So of course, those are the core kind of standards that we're going to like this encompassing system that then we're going to drive these lower level AI kind of activities. Um, Maybe a follow-up question to this, Edward. Besides 26, 26.2 and SOTIF, what other standards would you recommend as add-on for those getting into ISO Pass 8800?
Yeah, we have some references from the 8800. That means the 22989. That's a terminology standard, and also the technical report 5469 with the classification scheme. Where do you use this AI? Is this a software component? Is it as a tool for your development and so on? And that's very good to handle with this 5469 classification scheme. And brand new out of this standardization committee from last week, I have also a summary of important standards. They are not all published, but they are important. I will name them, some of them. It means that 8200 for controllability of automated artificial intelligence systems, and it's already published. Also the 6254 objectives and approaches for explainability for machine learning models and AI systems, also published right now. And also from the sub teams, will come some standards how to use the 8800 and how to use the tools. For the tools, it's the 22440 defines how to use tools in this AI tool chain, how to deal with it. And that's an updated version of the 26262. That's there are some more aspects added to classify and qualify the tools used for AI. And also sure, we have assessment of the robustness of neural networks, the 24029 and 24029 part 2, also for the assessment formal methods. And with the 25016, it's also out of this subgroup of the 8800 standardization body with metrics and methods to use for 8800. That's the brief introduction to some important standards.
Yeah, and I appreciate that. And I think one thing we have to recognize with the 8800, part of its objective is to give us alignment to non-automotive AI standards, right? We're kind of arrogant in our automotive way, right? Like we just want our own standards, and 26, 26.2 basically doesn't reference out anything except for itself. There's some minor references to, maybe some QMS like 9001 or 16949, but we have to recognize once we get AI, into the AI world or the ML world, we didn't invent it in the automotive industry, and there's a lot of organizations and industries that have been working on it for a lot longer. So there are established AI standards out there. So, part of 8800's job is to kind of align us to those non-automotive AI standards so it can kind of speak the same language. And I think, one of the first ones you mentioned, the 22989, I think that's one of the key ones, right? Because that sets up the foundation for terminologies and definitions that helps align us. And, we see things like validation, especially when you talk about validation data, has a lot different meaning than what we maybe think of in our traditional ISO 26, 26.2 world. Another one that you had mentioned early on, the 5469. So that was in a TR state, and I think that will be replaced here shortly by the 22440. And we've had this discussion, I think, one of our other fireside chats about using AI tools, what to do with it, because we go around the room and talk to our customers. Everybody's using AI tools, from developing C code or doing other activities. And we do have tool qualification in ISO 26, 26.2, of course, which was released in 2018, well before our great ChatGPT evolution that occurred during COVID or after COVID. So the 22440 takes a lot of that same principles, but has this adaptation in for AI-based tools. So we'll see how that works, once it gets published. We'll see the 22440 here shortly in the industry. I mean, there's already drafts available in this standard. So wow, I mean, there's just a lot of standards. I think it would be a summary. And I think one time I counted just the reference standards. It's over 20 standards referenced in this pass. So we definitely get into our standards fatigue kind of mindset here. But I guess one thing we know that separates ML development, from our traditional software development that we talked about a little bit earlier, is the importance of these different data sets. So I guess Gokul, what is the most common data set insufficiency or that you see teams overlooking before they reach, let's say the safety analysis? Because we do have an AI safety analysis, so that's very common. Or maybe just talk about what you see about data sets in general with regards to ISO Pass 8800.
Yeah. Before we sort of talk about insufficiency, we all recognize, those of us who work in the space with AI systems, that data is paramount, right? The leaders in this industry have a lot more data than the followers. And also, it's not only about the amount of data, but also the quality of the data, right? How representative it is, how accurate is it, how complete is it, right? Those aspects come in. Particularly now, we see a shift. Many of our customers are moving from more modular sort of ML models put together to end-to-end models. Therefore, in those cases, even the data set gets even more of a center stage. And to your point, like having data set insufficiencies or issues with the data set could make or break the performance of the entire vehicle, right? And causing some safety issue, quality issue, and also maybe in end-to-end models, some alignment issues could also happen, right? When we don't have the right type of data. So some of these standards, like out of maybe those 20 standards, there's also a standard called 5259, which is a really good standard on dataset quality. Also in the 8800 standard, in clause 11, there is a very good reference lifecycle for dataset, how to collect the data, how to perform safety analysis. Even there, they specify certain dataset properties, right? Having accuracy, having completeness, having independence within the dataset. We should have the training dataset that is independent from the validation of the test dataset. Having traceability, right? Understanding where the data came from. Was it collected from a real world testing? Was it augmented from some real world tests that we have in the past, and we sort of changed some parameters, or was it completely synthetically generated, right? And where organizations really struggle, and again, this is based on the past couple of years, we worked with these ML teams very closely. Maintaining the independence between data sets is hard. Also, how do you make sure you have a representative data set, that you don't have bias in the data set, right? How do you know that you have all the data that you need to sufficiently train the model, so that you know that you're not only really good on a major interstate in Kansas, right, where the roads are straight and everything is great, but also what about edge cases? And internally, we worry a lot about adversarial examples, right? Like, how do you make sure that you also account for those? Those are the places where organizations really struggle. And there are a couple of ways, and you mentioned safety analysis. That's a new concept. It is not a new concept to safety engineers, but definitely a new concept for ML engineers, right? That's where we are coaching a lot of our customers on, like, let's start walking in this space. We don't have to run yet, but at least using HasOps. And also the labeling, the curation part of data requires a lot of human labor, right? A lot of people are involved in this. Therefore, how do you set the right quality or right policies, the right quality expectations for labeling? Therefore, process FMEs, this is also something we talked about in a previous Fireside Chat. Process FMEs are coming back to the rage, right? Where we are relying a lot on the process side, even on the data, how it's collected, then this becomes really important. And many of our customers, when they collect this data and when they work on this in more of an R&D setting, they don't think about these. But when you want to go to scale, then you need to really have these in place so that you can scale and counter these insufficiencies.
I would just add to that last point is really a key one. There's a lot of tremendous advancement in the autonomous space, right? It's very exciting. It tends to be driven, which is fine, which is a natural course of things, driven by a research and development mindset. And just to repeat a thing you said, Gokul, but I see the same thing everywhere, and it's an important idea. R&D is fine, but when we want to make a real product that we put real people in the real world into, right, and drive on a public road where people's lives are at stake, then a lot of these processes, which are, I'll say that they're an AI or ML interpretation of some quality concepts, really, making sure we've done things correctly, define what we want to do, show that we've done it. All that applied to the data sets. It's a really important topic, and sometimes it just doesn't grow up naturally in an R&D environment. It takes a conscious choice to say, now we're in more like a production environment. Now we're going to take these things more seriously. For all the great advancements of some of these like incredible things that we see in the news, in the paper, we see on the street, right? Self-driving cars driving around. It's so incredible. But getting there requires a different mindset with respect to data sets, machine learning in general, quality-oriented procedures. They're really important, and sometimes they're a bit missing coming out of an R&D stage.
Yeah, and to that point, Bill, I mean, sometimes these standards come in and everybody gets a little bit scared, right? Oh, another big scary standard I got to follow. We were recently with a customer that's been doing ML development for years, right? Well before 8800 was, the past was ever available or even drafts of it. And as we were kind of walking through a lot of the aspects that the 8800 requires, they were doing it, right? Like, so, I mean, we have to kind of sometimes think of these standards as best practices.
Mm-hmm.
So if you already like thought through, hey, I want to do ML development right, or I want to I care about what I'm doing, then you're applying a lot of them. I mean, there are some gaps, of course, but it's not like it's a huge jump if you're really doing ML development correctly.
Similar to what we saw, I think, a decade ago in functional safety. For sure, some of the concepts were new. For sure, the ASIL rating scale needed to be harmonized and was new. But good safety engineers had spent a lot of time writing good safety requirements, right? Making sure that they had traceability in test cases. So there was, the standards didn't really invent safety. They codify it so we can all understand what is the state of the art and how to address it. So I think that same trend from prior iterations of technical advancement just plays out here yet again.
Yeah. So I think, what we'll see, and what we're seeing right now, people are doing ML development and, there'll be some alignment to 8800. Some organizations want that. And I guess on that note, like maybe transition a little bit to audits and assessments, and maybe since we have Eduard here, the expert, as we transition into, okay, I'm doing ML development, now I want to do it right against 8800. I want to kind of talk a little bit about, can we assess an audit to the 8800? We know of the SOTIF, I remember even when it came out, it's kind of difficult to do a product assessment with SOTIF. It just, how do you confirm, complete is complete or enough is enough? So Eduard, is certification possible with the PAS 8800? And with that, can both processes and product be assessed or audited similar to how we do in 2626.2?
Clear from this question, clear, yes, it's possible. It's very good possible. I remember years ago in the starting point of this 8800 and the standardization committee, there are a lot of members were also in the SOTIF committee. So, and there was the question how we will start with the 8800 standard. Do we will start from scratch? Do we refer to the SOTIF, start with the SOTIF insufficiencies seen from SOTIF standard, or will follow the 26262, understanding that we will have the objectives, requirements, and then the work products, and with description for each clause. And then the decision was clear to follow the 26262 because it's a very good auditing and assessment procedure in there in the standard itself. And so that's the reason why the 8800, it's a very good standard to have this audits and assessments for process definitions and also for the product from the product sides with the work products. Sure, we have some same activities or say the same activities in the validation phase, because the AI machine learning in the validation phase comes into the encompassing system with on the system level for the validation. And so somehow validation is this sounds to be the same as in from SOTIF perspective, and that's clear possible. I want also to mention all other AI standards we're talking in previous previous talk. There are a lot of technical reports and technical specifications, and not ISO standards and ISO pass. And pass means yeah only that it will be a public available specification in a 2 years time that we can very short react to the market. That's why it's a pass. And it's possible to certify also the 8800 defines a certification based on the 26262 basic standard. And it's also possible to say, okay, we have another basic standard for functional safety, for example, 61508. And therefore, for machine learning in automation industry, we use also the 8800 because the 8800 is for machine learning software components or software systems. And if they are implemented in not automotive systems, but in the industrial systems, then it's also possible to have this certification based on another standard. With some adaptations from our side, from SGS TÜV side, we have some adaptations, we have some to align it with not 26262, but with a 61508 standard. And that's possible in very, very good way.
I mean, that brings up a really interesting point. So I guess, I mean, although ISO 8800, starts out kind of a road vehicle style language that we're typical of seeing in 26262 world, but what you're saying is you can apply ISO 8800 to other products outside of automotive. With this, so yeah, I guess the thing that changes then is the base functional safety standard. Maybe you're using 61508 or maybe using 13849 as the base.
Exactly.
And then, I mean, with that, so right now 8800 uses 26262 and SOTIF. I don't know anybody on the phone here or Eduard as well. How about SOTIF as far as these other industries? I mean, humanoids or bipedal robots. Like, how does that work?
I mean, I'll only comment more just to repeat the question. I think for sure we see in humanoid robots the need for, let's say, for the idea of SOTIF. Maybe it's the same standard, maybe it's a similar ideas in a different standard, but I think the idea of SOTIF and then the 8800 for AI and machine learning, there's no doubt that the same ideas are somehow needed for robotics as well. And I don't know exactly where I think in some cases we apply the 8800, in some cases maybe we borrow some ideas from SOTIF, but I don't know the standardization of that and how that will flow. I think I'm very interested in trying to figure out and understand, because there are certainly needs, SOTIF style needs for many humanoid robotics use cases that are proliferating a lot now, right? You see a lot of humanoid robots. I saw one just to tell a little story, I was at CES and there was a robot that was throwing darts. I mean, it was cool to watch, right? It's kind of a fun use case, but as a safety person, right, I have my concerns. And I think there has to be some framework by which we really make sure if that robot's going to throw a dart that it doesn't do it in a way that's hazardous. There's a lot of ways for that to be hazardous, right? So there are these nominal functions and the ability to understand what's hazardous that becomes a pretty complex space in the humanoid robot world. I think that's an important topic for us, in the very near term. I don't know if others have experienced how to get that done from a standards point of view, but I know it needs to be done on the ground in a technical way.
Yeah, I think even before SOTIF standard existed, right? The three of us on our teams have worked in ADS even before a SOTIF standard existed, and we always rely on first principles approaches. And I think if you really take an AI lifecycle and how it's actually put together, and you apply just common sense safety thinking throughout that lifecycle, the 8800 or a similar safety lifecycle falls out of that, right? I think that's why, particularly for those of us who've been involved in level 4 autonomous driving for 12, 15 years, a lot of that is we know the right questions to ask, even in industrial robotics applications. And and we rely on the subject matter experts to really build the argument, right? And that's the exciting part when we've, of course, seen a lot of people from railway, from industry and consumer devices come to our 8800 training, because I think people see the value of the standard being useful across multiple industries.
Yes, yeah, go ahead, Eduard, sorry.
I think we have to take into account that the standardization body represents the state of the art. And the state of the art means that you shall have on the market some previous activities in this kind of SOTIF activities or functionality descriptions, or also in 8800. And if there are not some previous working done in the market with some matrix, for example, or some reliability data, so we know from the 26262, for example, they are old, and we have no matrix, for example, for this 8800 pass, then we cannot have some state-of-the-art definitions in the 8800 worldwide as a requirement. That's why there are no matrix in there. We have to some basics to define this kind of matrix, and that's the previous work you talk about it, I think.
Yeah, and I think, whether like we use SOTIF in other industries or not, I mean, we still have to ask these other questions, right? Because just going back to the humanoid example Bill was mentioning, I mean, humanoid can carry a very hot object, which could easily burn to pretty severe injury to a human, or they can carry sharp objects, right, and just kind of twirl around. Those are not really malfunctioning behavior, right? Like 61508 or 1349 is not going to handle that. Somebody's got to deal with it. I mean, SOTIF in our automotive space kind of gets into that space of this kind of hazardous behavior type questions, right? This basically all it's asking, like, what are the hazardous behaviors that your vehicle can go into? But what is the hazardous behaviors of a humanoid? So I think we kind of need that as an input into this. I guess before we get off of this certification topic, Eduard, at SGS TÜV, have you already been providing assessments or audits to customers in the 8800?
That's a great question, yes. Yes, we have some certifications already. I can talk it because we see it also online. We represented in China the automotive part, the Geely or Heroin. They are certified for the process based on 8800 from our side. And they're also the basic process also in there. So we had also consulting activities with our colleagues from SGS China. And there's also a colleague in the standardization body from the representative of China. So we have the independencies of the consulting activities and the audits, and the audits were we have done online. So we finalized it now for process, and the future we will also certify product certifications. That's from the Chinese market. The German market, it's somehow behind of that, the Chinese market, but we have also some quotations in the pipeline for the German factories.
Okay. So I'm assuming that, for a product certification to 8800 kind of follows the same idea of 26262, where you have to have a process audit first, make sure processes are in place. Are there things that are important in the product assessment that you'll be looking for, or what kind of aspects maybe outside of processes or inclusion of processes are important for the product assessment?
Yeah, that's also a great question, because that's also the questions we have from customers who they will start with a process definition and so on. It's important to have a process definition as an overall process. That's what we certified already. And it's also important later on for the product that with this view from our side that the process was following by this product development. And from the work products, it's also possible to have, in the most cases, they have templates or some definitions how the reports or specification shall look like. And that's a pre-step to have a review of this. And at the end, for the product certification, sure, the following process, as I mentioned, the following process is important, that the process defined was followed for this product, and the work products and the specifications that they are with the traceability to the encompassing system, very important, also in the specifications, not only from the process perspective. And the requirements derivation is following from the item 26262 through the SOTIF aspects in the most cases, and also to the 8800, and this definition then in the work products of the 8800, that they have the whole picture and the whole safety arguments, I will say, with a safety case, and inside the safety case, the assurance argumentation from the 8800. And that's the whole picture with evidences for the functional safety.
Just one comment to that. I mean, I think it's worth pausing and just highlighting, I think, a key point you mentioned, Eduard, because it's maybe it's a traditional automotive mindset, but it's a mindset that is still, let's say, it's still developing for some of our customers, especially in the US. I think you said a thing that's really key, which is we have to define a process by which we show uh, good adherence to standard requirements and to good safety practice, and then that process comes first. I say that out loud. I think that's not controversial on this call, but there's some of the customers we have, some people we meet, they're just not process oriented. Maybe they didn't grow up in a process space, and so I think that's a change in mindset. I think especially if we're honest in the U.S., there's a lot of tech industry organizations with tremendous capability in some ways, but not process first. And I think to be safety assured, I think what I heard from you is that those processes really, they're important, and they're important maybe as a first step. And then when we look at the product, having had first defined and ensured the correctness of the process is maybe a linchpin. It's like a baseline from which we can take any step with the product. That's a different way of thinking for some of our customers, I think, in the US. But it's a way of thinking probably they'll need to develop over time, is my guess.
Yeah.
Maybe I had one minor question, Eduard, also for you. You mentioned you have it sounds like significant traction for uh, doing this type of work. So for the certification work with 8800, um, it sounds like significant traction and maybe earlier traction in China and in Asia. If possible, can you comment on the market driver for this? Is this required or strongly preferred in China from a regulatory perspective? Is that in order to enter the European market? Maybe every customer is different in their motivations, but can you comment a little on the driver for China being sounds like the earliest customer base for this kind of certification?
I think the first step, they have no fear to do something wrong, and they started, and so, sure, we had some loops for this
Sure.
definition of the process. And what I see from these customers who had that they talk directly and say we will be the first. It's really easy. They say we will be the first with a certification for the 8800, but we will be the first. And that's, I think that it's also mentality, and no fear, will be the first. And the German mentality is we have to define, that shall be clear, and that shall be defined, and that shall be a process that we can follow, that we will pass the audit. And so they're a little bit careful, and that's, I think, our mentality.
Yeah, very good. Very interesting.
I think we see that also not only in AI, we see it, I think, in a lot of other topics. So, but that I see here, they make not a lot differences. They define also processes, define also the work products, use also the same tools we have here in Germany, for example. From, don't know, in US, I think will be also the same, or something in the middle maybe. And they use the same as we do the same as we do, but they do it fast without fear. And they say, hey, we do it, and again, and we will have 5 loops of consulting, then we will have 5 loops, but we will do it and we'll be the first. And that is, it's a push somehow from the mentality.
Yeah, it sounds very familiar. I think I can remember. So I'm an old guy. I have the gray beard for on behalf of Secure Safe LLC. But I can remember when we saw China long ago as a kind of like emerging automotive industry, sort of growing up from a low base into something real. I think now when you see the activity there in autonomous everything, it can be for vehicles, but also for robotics and other things. As you mentioned, I think we see the same tools, the same methods, the same Nothing that's even a half a step back from what we would see in the US or in Europe in terms of technology. And as you mentioned, I think I've seen the same thing. This commitment that we go do it, we're going to be first. It rings true to me. It's what we've seen with some of our customers as well.
Yeah, and somehow they push us also to provide the services and to be also the first, and so they indirectly they push us also. And in the end, it was okay. It was good.
That's great. I mean, that's really interesting. I guess one thing we talked about briefly about metrics. I would think like metrics are going to be kind of a key aspect of this product assessment, right? Like once we move to the product. And in the SOTIF world, we speak a lot about SPIs or safety performance indicators or KPIs, whatever you want to call them, which again are more related to the vehicle level. I think a question that we see quite a bit with customers, what's a SPI for ML model? Like, am I taking an SPI at the vehicle level and I'm kind of transitioning that to the ML model, or am I using the SPI at the vehicle level as evidence for my model level, or is it completely different? Like, do I have to have a low level SPI for the ML model? I don't know, Bill or Gokul, if you have thoughts there.
Yeah, I mean a few. So for sure, I think we see both referenced in standards, but also in as Gokul mentioned, maybe good common sense safety practice. We want to have the safety equivalent of KPIs, right? Safety performance indicators. They're very valuable, very powerful idea. I think the original idea of those is really to track trends, right? To show that we're getting better, show that we're improving as we, for example, evolve our software or evolve our vehicle, whatever we're working on, that it trends towards something safer over time. And they're valuable in that way without an absolute value, just to simply say we got better and we didn't regress, right? And it's almost a metric that shows us that trend. I think when we look at the kind of metrics you would have for a full vehicle, right, which may be an incident rate in the field or a number of incidents that would occur in a human overseen test, for example. There's definitely a linkage between vehicle level metrics and lower level metrics. Lower level may be perception, right? We can always we can evaluate perception for false positives, false negatives, have some valid numbers regarding how good they are. We know that there is a linkage between these, and it's right to call out that linkage. I think what's frustrating to people sometimes is we don't have, and my personal view is I don't think we can absolutely define an absolute mathematical link between those. So people want to say, hey, how good does my perception have to be in order to guarantee that my vehicle function is good enough? I think that's just not a linear thing that from my perspective is really doable. So we want high level metrics, we want the low level metrics, we want to see them improve, and the one contributes to the other. But I just don't see that direct mathematical link that sometimes people want. So there has to be some amount of, I think, estimating to start, and also getting good feedback from field evaluations and from simulations to really drive the right targets. It's very difficult to sit in a room with a whiteboard and say, X number of incidents means Y number of perception faults. I just don't think the math works that way. Conceptually, it's that way, but working it out is challenging. And where we often see the best real world work is that what scenarios do from a SOTIF perspective, when we discover these unknown scenarios, they get focused, right? So we sometimes have a narrow view where we say, look, we know 90% of the problem is solved. Here's a portion that isn't solved and that we realize we have to do better on, and then there'll be intense iteration to drive metrics better for that scenario or for that category of scenarios. So the metrics are tremendously powerful, they're necessary, but I don't view them as like connecting them in a sort of a big math. I think people want a big math model about how everything fits together. That's a really hard thing to do. Maybe in some cases impossible thing to do, in my opinion at least.
And this question, and this comes up every single time we have this conversation during a training session or in a consulting setting. I think it's the right question to ask because it comes from a deep need for ML engineers and data engineers to define what is done, right? What is the definition of done at the model level? And they want to tie it to something at a vehicle level. I think the intention is correct, but also when we have dug deeper with some of these customers, what we have found out is at the model level, the KPIs are useful, but also there's always a lot of trade-offs that are being done all the time, right? Each time you go through your epochs of training, maybe you choose to sacrifice a little bit of performance for more accuracy. Maybe you choose to improve accuracy with your predictions, but it's okay to be a little bit maybe slower or maybe a little bit more coarse, right? I think at the SPI level is a much better metric for us to validate against. With a lot of freedom that we can provide ML engineers and data engineers at the lower level. And particularly, I think it's helpful to capture some loose coupling between SPIs, right? In order to meet these SPIs, we believe these KPIs are important rather than a tight coupling of only if these targets are met. To Bill's point, I don't think we need tight coupling, but some loose coupling is still useful between these two. And may not be satisfying, but I think that freedom is useful.
I'm glad this is recorded because I feel like that last 30 seconds is exactly right. I wasn't able to articulate it in my mind, but you nailed it. That loose coupling, I think, is a powerful idea. It's not that there's no link. It's merely that we can't. I think we have an engineering urge to define that we met all the low-level requirements, and therefore the top-level one is met by definition. This problem doesn't lend itself to that. That loose coupling idea, I think, is from my point of view, is like the one that works in a practical sense and that we bring to customer.
Great. And I guess, Eduard, I'd be interested from an assessor's perspective, especially as you move towards product assessments, if that becomes mainstream, like what will be the view of an assessor for SPIs for model ML development? Any thoughts on that or?
Yeah, I have two thoughts on that. One thought is there is in the subcommittee from this 8800, a body with a ISO PVI 25026. And there we try to define matrix supporting methods for evaluating road vehicles AI safety. That's the name of that. And so we summarize all the matrix from the 8800, from the SOTIF and 5083 somehow to give these KPIs. And as an assessor view, for me, it will be the best that we have somehow some kind of single point fault metric with definitions. And for me, it's clear. It's with a mathematic behind of that, it's represented and it's clear. For me, it's okay then to say it's good or not good. And from now we have the most questions that please SGS TÜV, you have a look on our product and is that enough? I think these questions are also from the SOTIF perspective. Is that enough what we do? We have KPIs, but we don't have the values, how much is enough or how much is not enough. And the difficult from our perspective is that we have our experience in AI, but the experience also on the products we audited, and we're not a R&D company. And that's a very, very good question also from us. It's enough or not enough, and to which KPI, which value is the limit of that. And so we, in the most cases, we go then in the discussion, like a brainstorming with the customer, what can happen if this KPI on this level will increase. And so when it will be a failure or when it will be, you cannot give the evidences for your function, for example, and kind of like that, we have to define maybe today in a conservative mode that we say, okay, that's the limit of that. Maybe we can do more, but for now it's not possible. And so depends really on the customer and on the product, which KPI limits we will have and which metric we can use to that. And sure, of the functionality, for example, if we have an industrial application with a camera view of an area, then you have no movement targets, and then the car the car is moving, and you have each second you have a new picture around the car, and it makes it also difficult to cover all scenarios and to define one KPI, for example, for one function for all ODDs, all scenarios.
I mean, I can see kind of the complexities that we have in SOTIF as well, right? Like it looks like it's gonna play out also probably in product assessments here. And I guess before we talk to about the future of where ISO Pass 8800 is going, Bill or Gokul, I don't know if anything we missed. So I know we've been working on this from a consulting view for over a year since the pass has been available. Any points that I maybe missed or that you'd like to bring up that you've seen?
I think emphasizing, and we should give kudos to the authors of the 8800, including Eduard, right? I think it reflects what ML engineers and data engineers do. When we talk to our customers who are doing this, they don't feel as intimidated or they don't push back as strongly on 8800 as maybe we've seen with other standards, right? Because it reflects kind of what they do today. Of course, it is more rigorous and more process heavy than what they're used to. And that's where there is some discomfort, productive discomfort, right, to sort of solve them. I think generally where I feel like the organizations are realizing, and particularly some customers we work with, they're now realizing because they didn't have it written down formally, because they didn't track it for change management, they're doing a lot of rework now. Because now there is an organizational mandate to go, stakeholders are knocking on the door and asking, how do I know that your AI system is safe? Customers are asking, I want to audit your AI system. In those cases, they're realizing that if they had written this down, actually they would have had a much easier time now, and they're not doing a lot of rework. So I think we are seeing some of these organizations who are at the forefront sort of seeing the light a little bit, that as long as we can tailor and sort of build a practical process that works for a particular company, I think 8800 shouldn't be as intimidating. As you mentioned early on, Jody, like people do this already, right? It's not completely new. 8800 is only reflecting what these ML teams are already doing.
Yeah. I mean, just to repeat the same point a slightly different way, I mean, some of these machine learning and AI topics are extremely complex, right? But some of them aren't. We have to have change control, right? We have to have configuration management. We have to have high quality data sets which are traceable and repeatable, that are well labeled, that we've verified the correctness of. We have a process to build. These are really quality oriented processes applied to AI and ML. And I think, I mean, again, Gokul kind of already mentioned it. I mean, there's companies that are learning the hard way that all that is really required, right? And again, when you grow up in an R&D mode, it's a way to move very fast, but it's also a way to sort of set all these topics aside. Well, they come roaring back as soon as you want to have a product. And I think that's what we see with interest in the 8800, and that interest increasing because of that need to have a baseline of what processes make sense and what processes are viewed as industry standard, industry state of the art. Some of those processes they're not rocket science, but they're critically important. And it's just sometimes, honestly, they haven't been built. And I think organizations are starting to understand that they need to be built for anything that's a product.
I think the most important topic is that it represents the state of the art. It's defined, it's written down, it's state of the art, it's an ISO pass, and it's released, and you can follow it and say, I'm following the state of the art. And that's behind of that, I think, very important to say.
Yeah. So I think kind of summary, there's a lot of uncertainty with ML, and we need these processes and aspects described in 8800 helps kind of define a path for us to lower those risks, maybe to these uncertainties. So we won't eliminate uncertainty to zero, right? Like we won't get it to absolute, but through these processes, good practices, we can hopefully lower risk. I know we're kind of running out of time here, but I did want to talk about what the future looks like for the 8800. So as I mentioned, it's in the past state. I don't think there's the official release, and I don't know if we call it the second edition or it's the first. I guess it's the first real edition, first standardized edition. That's not coming until 2029. Maybe Eduard, can you walk us through some changes you expect or what kind of inclusions there might be in the future?
Yes, actually, we work on that, on this subgroups for tools, and that will be implemented somehow as an annex or an PBI, and also with this metrics and methods to use them also to in this 8800. We have from the past, from the first edition, we have some comments. We we step back because we have not the time to develop it, that we can release this first edition, but they will be implemented in the second edition. And one big point is that the second edition is divided into parts. It means the part 1 represents the definition and concepts. Then the part 2 defines the general requirements, and the part 3 defines the refinement of machine learning, with part 4 applications example for machine learning. So, and this part 3 and 4 can be also in future extended with new AI technologies, for example. Then these parts can be extended. That's a very, actually that's a state now. But we started with the commenting of this first edition with proposals for the second edition, and developed some initial proposals from each committee. And so, yeah, that's the work on it. There are different proposals, sure, to for part 3 to provide detailed verification validation guidance on based on industry practice, for example, with methods known, not new methods, but known metamorphic testing, statistical testing, keyway combinatorial testing, so, and how to use it in the automotive 8800 view. And so that's in this all in discussion. I think right now from the process development view, there are some activities or some ideas for safety monitoring in latent space and so on, and some ideas also for the data collection and some enhancements. But it's all now, it's in a commenting phase, and now in not clear in which direction it will go. It's a summary of different collection, also from the German committees, from the national and in the international committee. They will then be collected and summarized. The work is done. We had the last meeting was in New York in December, and in January we had already, or beginning of February, we had already online sessions. And so mid of the year we will also have sessions in maybe in Canada or in somewhere else. But you see, the work is we go in the next steps, that we will not slow down, but we could do the next steps in I think two month rhythms to collect this all of this commentings.
Okay, so it seems like parts 1 and 2 are kind of what we're looking for, or what's more normative, I guess, aspects that will be coming out in 2029 timeframe roughly, and parts maybe 3 and 4 more informative then, and they'll come later, or?
No, they're not informative.
Oh,
they are normative. They will be normative because it's divided only in the different parts.
okay.
And sure, if we talk about example, maybe that will be not normative, because example can be enhanced, can be used. And but I want to mention also the adversarial attacks are also discussed, and also discussed how it is aligned with the AI Act and the accuracy, robustness, and cybersecurity. Somehow we come from there and have to define it in a detailed manner for these standards. And I hope, and hopefully, that we can have at the end in the second edition some metrics, some values, or some more detailed verification validation activities, because that was also a lack of the first edition, as I know from our customers, because they want to know how we can validate it directly from the engineering perspective. And so hopefully that will be defined in a detailed way, that it's more usable and will be better to use than for the customers. It's zero. So what's also new, I'm sliding shortly down to my notes here. Sure, the industry pain points, E2E machine learning for the emergency mainstreams approaches, and in this direction we have these discussions. There are not all discussions of this what I mentioned that are from the German perspective, and we're also from Canada, from Japan, from all other regions with the commenting. And somehow it's the actual phase is the collect all of these comments from all national standardization bodies. And I think mid of years and end of the year, we will see some more insights with some outputs out of that.
Okay. I guess one last question I had on that. You'd mentioned the EU AI Act. I guess it's an interesting question for you since you live in the EU. Is the intent, or will there be intent that for those organizations that want to kind of comply and follow the EU AI Act, that if you follow the future ISO 8800, that you kind of are compliant, or is there going to be more activities outside of the standard that would be required?
Yeah, the EU AI Act is on very high level. For automotive, we don't use it directly, but the EU AI Act say you have to define some standards in the standardization bodies, and here we define the 8800, and if we look back, sure, we come from the AI Act, we have to define something. We cannot use the AI Act directly for our usage in automotive, but we have defined something, and sure, if we talk then about 8800, we defined for automotive industry the state of the art, how to use AI in safety applications. Then we go back and say we represented the state of the art, the ISO pass, and that's aligned with our EU AI Act. And sure, I not mentioned, through the regulations we have, national regulations from the German perspective, for example. And out of there, we have also this, I think, deeper standards, the ISO. And then we have traceability directly. Again, from above, the EU AI Act, we defined regulations, we defined ISO pass 8800, second editions, and that back represents the state of the art required from defined from the EU AI Act.
Okay. Well, thank you. Yeah, so it definitely seems it could support it, but other things will be necessary. I think we could all talk probably for another couple more hours, but unfortunately, I have to cut off here, otherwise it gets too long. So I want to thank Eduard for joining us. Gokul and Bill, as always. And yeah, look forward to our next discussion. Maybe Eduard will have to bring you back for another discussion in the future. So thank you everyone for tuning in. Again, reminder, please put those questions into the chat and we'll try to get answers to them. Otherwise, we'll answer offline if we can. All right. Thank you. Bye.
Thanks.
Thank you for my side.
Thank you.
Thanks, guys. Bye.